Hi, this is Fabian Landry, and this is CodeDoc by Feel It. In this part of the CodeDoc story, we are going to continue from where we left off in the last session. We are going to go over a few tips related to that. After that, we are going to jump right into it and code a real life application in the form of a calendar. Let's get started. In the Hello World application, we discussed a few tips on how to write, build, and run our app. But we really did not talk about an important aspect of development, and that is debugging. Debugging is the controlled assessment of a code's execution. Let's see that in action. Our current build configuration is debug. We know this by checking this option. We could also change it to release, for example, or have a custom configuration of our own. But the recommended way of going by this is using debug while developing and release when deploying your app. I've just initiated a build after changing to release mode. Let's see how it goes. There, you succeeded. Now I'm in the folders, in the location of the project. Going to bin directory. This is where, as previously mentioned, our app executables go. Go to the release directory, .NET 7.0, and you can see the executables are there. I'll delete them for now, just to be safe, and initiate a new build. There, it's done. And there we have the executables are back. Make special note of the PDB file, Program Debug Database file. Now let's go to the debug and net7 directory. We see that the same files are here. Delete and initiate a build just to be safe. And there we have it. The program debug database file should never be deployed with your app. So let's go right ahead and debug our Hello World application. We do this by setting a breakpoint by clicking on the side here. That's a breakpoint. That's where I expect the application to stop. After execution or initialization. So set a few breakpoints here and there and run the application. After changing my layout a little bit, I'm ready to start the application. I press on the button above and let me retrieve the debug window, the console window of Visual Studio. And there, breakpoint was hit. You can see that by the yellow colored bracket. And nothing is written to the console right now, simply because no code has been hit. No real code has been hit. No message to the console, nothing in particular, just the entry of the application. We can step over, step into, or step out with the in the debug mode. We're gonna up to step over, and so far nothing in particular of note, just that the arguments are not provided, so it's an empty array. Once we step over the message variable, we see that it says hello world, welcome to blank. And that's the same message that's printed to the console. Now, there's one more thing I would like to show you in relation to debugging. If we go to the properties and in the command line arguments, we specify the argument that will be provided to our application when it runs, which is simply a string of CodeDoc, and press run to run the application. We are at the same breakpoint we were earlier, but if we notice, the arguments are now with one item, string item, in the index 0, which is CodeDoc. And the message to the console should be, welcome, hello world, welcome to CodeDoc. This is how one can effectively debug the application and ensure that the mechanisms that are put in place are as they should be. That's what's meant by controlled assessment of a code's execution. So let's do a small recap. We learned that debugging is a controlled assessment of a code's execution. We also learned that the best way to go about to debug is to use the debug build configuration and release when deploying. That was it for the Hello World application. Let's now move on to our next topic. Next topic is an assignment called Fill It Office Work Calendar. This assignment is not an original Fill It assignment, but we feel that the solution is. Basically, the assignment requires the creation of a calendar that also enables the end user to calculate working days. The calendar should be able to calculate the distance measured in working days from a given date. A working day is defined as any day from Monday to Friday except for defined holidays. The calendar has two methods that define holidays: set holiday method and set recurring holiday. The working hours can be set with set working hours method. The method that calculates the distance must always return a time that is within the working hours. However, the start date parameter that it takes needs not adhere to this constraint. This means, for example, that 1505 plus 0.25 working days should return 0905, and 04 plus 0.5 working days should return 12 p.m. Below is the cheat sheet or the test results or the test criteria. There's one additional test criteria, and that is that the 17th of May and 27th of May of 2004 were holidays. We're about ready to start our IDE, Visual Studio. We could continue without code, but I'll opt to create a new project. And search for class library. A class library that supports .NET and Net Standard. Select that and click Next. We've been here before. I'll select my working location and change the project name to something suitable. Fill it Office Work Calendar C#. That's good. And we could select Net Standard 2.1 or 2.0. We will go by 2.0, which is supported across the board. That standard is nothing more than a formal specification of .NET APIs that are available on multiple .NET implementation. Alright, we have a new fresh project open. We have a class1.cs file. We just change the name of this file to something that represents our task. Workday Calendar should do just fine. We press enter, and we should get a question of if you want to rename everywhere else. We click on yes, and note that the class changes its name. Now we're ready to code. I have the assignment on my right side so you can see it all the way through. The first thing we want to do is take notes on what we want to achieve. So the first step is A. Determine month types. Month types are nothing more than the months January through December. We could define them as constants, 12 different constants. Um, or 12 different integer constants. These are not constants, but we could add the keyword const in front of the int to make that a constant. Now we have January and February as constant, while December isn't yet. Now it is. But they are not so, they are not related. We have three separate, well, in the end 12 separate variables that are not that have no relation whatsoever, and that makes coding a little bit different. So we tried the enum instead. The enum is defined simply as writing a public enum we call this month type. In the month type, we start by opening bracket and close with opening closing bracket. We start with the first month, which is January, should be equal to 1, and so forth. June, July, August, September equal to 9, October equal to 10, November equal to 11, and December equal to 12. That's if we see from the Gregorian calendar's perspective, and that is basically what we will base this assignment on, the Gregorian calendar. We might just as well write B, determine determine calendar, type of calendar, and we decide that it's a Gregorian calendar. Yeah, change that to A. We don't need that anymore. The next step we want to do is C, define the holiday type. Now the holiday we want it to be either a class or a struct type. An integer, for example, is a struct type, which is a value type. A class, regular class per definition, uh, is a reference type object. But first, we want to move this code from outside of the Workday Calendar class. It was within the Workday Calendar because of the closing brackets. But now we define the public class holiday. We start off as a class, but it could also be a struct. Uh, but we define it as public holiday class and define the first item we can think of, and that is day of the week. The day of the week lives in the system namespace. We just start by public day of the week, and we make it with a property which has get and set properties. Get and set allows for read, that's get, and set allows for write. So right now they by default are public. The same thing with day of the month, get and set, but of type int, integer. Now the next one is the month type, which is the enum we just defined. Makes it also a property of get set, and then the year, which is of type integer. Now we have finally defined our holiday object. We're missing one parameter, which is recurring of type boolean. That should do it. So every time you see get and set, you should automatically think properties, which is what day of the week and so forth are. Uh, but there are also another type of variable called fields in a class. And the best way to go about showing what that is introduce a type called struct. Now we should have everything we need to get going. So we go right ahead and declare our holiday container, which is of type list, with a get and private set uh, accessor, private write access, and public get access. Seemingly, at least that's what it looks like. There's an issue here, but we'll discuss that later. We can make a note of it being private. The next types we want to define are the workday start time and workday end time. So let's go ahead and define them. They are of type time span. A time span represents nothing more than a duration of time or elapsed time. Now we define both our workday types with get and private set, just like the holiday container. Now we have them defined. If you notice, you'll see that it's suggested to enable the constructor. This is how the constructor of the class looks like. The constructor allows us to create the class if it's not defined when no other constructors are in place. we don't need to define it, so it's commented out for now. The next thing we do is to declare a method called setHoliday per specification, and it takes in a Gregorian calendar and date, date. Now we start by checking if the calendar is null. A null is basically equivalent to undefined. And if something is undefined, there's basically nothing you can do with it except checking for it being defined or not. And that's both the beauty and horror of null. So what we have decided in our code is that if the calendar is null, we throw argument null exception and pass in a parameter name of calendar, which is nothing more than the name of the variable calendar. The next thing we want to do is store the holiday date. We don't have a method for it yet, so we just write store holiday date. We expect it to take in the calendar, date, and is recurring equal false. To generate the method, we can simply click on Control Dot on Visual Studio for Windows and enter, and it allows us to generate the method that we need. Now, make special note that we have now set holiday coupled with the Gregorian calendar. We cannot use any other type of calendar with set holiday. And that could be good in some cases, but I've decided, since I'm the developer of this application, that it's not adequate. So if we control click on Gregorian calendar, we can see that it inherits from calendar. You see that by the colon in between them. And calendar is an abstract class that interfaces iClonable. An abstract class is nothing more than an abstraction, an interface, you can say, with specification of how of the behavior of the class. Now, since the Gregorian calendar is a calendar or inherits from the calendar, moreover, we could simply replace the parameter calendar of type Gregorian to calendar. This is also in many instances referred to as polymorphism. Polymorphism stands for many forms, or one name, many forms. And that is basically what we are trying to achieve here. We implement store holiday date next, but first let's rename it. On Visual Studio, please press Ctrl R, Ctrl R. So Ctrl R, and rename and enter. One more thing before implementing store holiday date method is making the date parameter nullable. And this is done by adding a question mark like this, which the store holiday date is not happy about. You see that by the red line under the date variable. The next thing we do is write datetime data set equals the current date. This is defined in the datetime now property. And data set we set equal to, first we check if date has value and then question mark. That means if it has value, we set it to a cast. That's the parentheses. Datetime, we casting. It means we're changing the date value that's nullable to a regular datetime. And the colon, date to set. And we pass date to set to the store holiday date method. What we have written here is that if date set has value, we pass in the value that came in of date. If it doesn't, we pass in the value of data set that it had before entering this point. Now we're ready to implement store holiday date. First, let's rename the bool v parameter controller to is recurring. The next thing we want to do is remove the throw new not implemented exception. First, check if the data has already been stored. The way to go about this is to first get the stored holiday if it exists. That's a method we haven't created yet, so we generate it with control dot, enter. It takes in a date parameter. Let's go right ahead and terminate that with a semicolon. Alright, the next thing we want to do is to implement get stored holiday if it exists. So we remove the throw new not implemented exception. What we want to return from this method is a holiday that has the same day, same month, and same year as the one stored in the holiday container. We'll achieve this by making use of link or link queue expressions. Link comes in two flavors, or rather link queries. You have the query syntax and the method syntax. We will make use of the method syntax, and as far as I know, there are some operations that can only be expressed by using the syntax. The syntax is as follows: var found holiday equal holidays, our container, dot where, then we pass in a lambda expression where we compare any given holiday against the holiday or the date that is provided as a parameter. The date month is an integer but can be cast as a month type because a month type is an enum. We also check against the year. This will return all cases that match this lambda expression. If we only want to return one case, we could use first or default, which will return the first case that matches. There's an issue here right now because the date.day has a lowercase. We should change it to uppercase. Now everything is okay. Now we have a holiday returned, but this could be simplified if we wanted to. So let me just comment this and paste a copy of it. Now we could just copy the first default and replace the where expression, and that's it. The above could be replaced to just the first default with the lambda expression. Next thing we do is return to our store holiday date method and check against if found holiday equals the default of holiday. I have one issue about using this condition, simply because conceptually a default holiday doesn't exist in this implementation. So we have to find a different solution. We could of course use any in the link expression, the any extension method. The method would return true if there were any matching record in the collection. But we actually want an actual holiday return. In short, we will be better off with a nullable holiday or a reference type holiday. So we remove this equals, and use equal null, and immediately we have issues because a struct cannot be conditionally compared to null. So we go ahead and add the nullable operator on the holiday variable. We do that as well for the return type of get stored holiday if exist. We will also have to make the type of the container nullable, but we can do that later. For now, we can see that it's a list of holiday, and we're returning a holiday, even though this is a nullable. So we change this to holiday nullable type. Now we have a local variable that's nullable. But it won't work if we don't change the holiday containers list of nullable holiday. Okay, let's go back to our method. The next thing we want to do is figure out which day of the week it is, because it's the only unknown parameter. Make use of our input parameters to figure out which day of the week it is. Then we add the new constructed holiday to our container. We know that the day of the week was equal to the newly created day of the week, while the day of the month is equal to the day that's residing inside the date parameter, and the month type will have to be cast from the month that resides inside the date parameter. The year is the year that resides in the date parameter. We also pass if it is recurring or not. That basically concludes our condition. If found holiday is null, that means if it's not previously in the stored list of holidays. The next thing we want to do is add a new condition, which is an else if recurring. That means if it's not null but is recurring. The first thing we want to do is locate the index of found holiday in the list. The index would have to be is returned as -1 if not found, and the zero base location if found of the item we pass in as a parameter. We currently have an issue with found holiday with an index of extension method, and the reason is that found holiday is a nullable type and index of takes a non-nullable type, but we can easily solve it with get value or default. The next thing we try to do, I say try because I know how it'll end, we set the is recurring field of our found holiday variable to true. The reason we set it to true is because we could have a situation where we retrieve a stored item from the list that is not recurring and has the same date as a provided date that is supposed to be recurring, if that makes sense. We have an issue here, not a major one, but a significant issue, because it would require us to do some things that I don't like about this implementation. So, but first, let's illustrate what the problem is. Is recurring is a field that should normally, under normal conditions, be accessible like we just tried. But found holiday is a nullable type. It is also a struct, and struct are meant to be immutable, which means they are not meant to be changed. We could access the value property like we would normally do with nullable types. We could even use get value or default, or even cast it. But that won't do any good because the holiday object is of struct, and a struct nullable makes it very hard to access its fields. That leaves us with one option: to reconstruct the object in order to update one field. And that's the thing I don't like about this implementation. So I would like to change it. But before changing it, let's look at how things would look like if we continue this route. We basically create an instance of the holiday struct and replicate the found holiday for all other items but the is recurring, which we will have to set to true. To avoid doing this, the change that is required is quite simple, really, and it was right in front of our eyes all along. All that is required is to change the struct object that we have created here to what we previously created, a class holiday with get and set properties. So we proceed further down and locate the one line code of found holiday is recurring equal true, and we uncomment that. We don't need get value or default anymore for any of the cases, and we don't need this at all. And we remove the nullable markings. We don't need them anymore. And we might as well remove this. We perform a check of the index to ensure that we write safely. With an if statement, we check if the index is greater or equal to 0. Then we set the stored holiday equal to found holiday on that particular index in the list. Else, if we have an else, then we have a framework error. But we handle it anyway, because if there's actually an item that is equal to found holiday in the list, an exception will occur, and we want that to happen. We are actually done with the set holiday method. Now we can go ahead and implement the set recurring holiday, which should be pretty straightforward. It's virtually a copy of the set holiday method, with the only difference being that the is recurring that is passed to the store holiday date method is true. We have now completed two methods that were supposed to be publicly exposed. That was set holiday and set recurring holiday. The next method we supposed to implement is set working hours. The set working hours method should be pretty straightforward. All that would be required for us to do is set these two properties: workday start time and workday end time. So let's get right into it. As mentioned, this should be pretty straightforward. We write public void set working hours, which takes in a time span start and a time span stop for the start and stop of the working hours, and assign them to workday start time and workday stop time. We'll go right ahead and implement the last method that needs to be publicly exposed, and that is get end time based on working day increments. That should have a return type of datetime and take in a daytime start date and a float of increment in working days. One important piece of information is verifying if the increments are positive or negative. So we can do just that and store it in a variable called compute positively. We can set that bool compute positively equals increment working days greater or equal than 0. That basically means that if increments are positive or 0, we compute positively, otherwise negatively. What that means we will know further in the code. Now the next thing we want to do is define a variable named normal workday length, and that is equal to workday end time minus workday start time. Let's rename the workday end time so that it doesn't get confused with this method. So we change end to stop for the workday start and stop time. So let's move on. The next thing we want to do is to check if the workday length is less than time span 0. So we want to check for negativity in the normal workday length. Then we just add 24 hours to it. Next up is defining a variable called effective hours, and that is defined as the absolute value of the total hours coming off the time span of normal workday length multiplied by the increment in workdays. The absolute value is the positive value you get regardless of the input. So minus 5 is 5 as an absolute value, and plus 5 is also 5 as an absolute value. We have an issue here with the total hours being a double, which will result in a double as a result. That means that either total hours need to be cast as a float, or effective hours need to be a variable of type double. We will opt for effective hours being a double. Proceeding, we define a variable called effective work hours increments of type time span and set it to be constructed by the method from hours provided by the timespans class. This is basically the effective hours converted to timespan. Next is declaring two new variables, both of type datetime, called current working date and output date, and initialize both of these variables with the value of start date. Next is declaring a variable called allocating working time with an initial value of true. This value will be used in a while loop, which will run until as long as it is true, and the value will basically compute the end time in the end. That's the goal, at least. Inside the while loop, the first thing we want to do is check if the current working date is a holiday. So if is holiday, this method unfortunately does not exist right now, so we have to write it and create it. If is holiday current working date, we skip the current date and get the next working day. You generate the method and we go right ahead and implement it. First, we rename the current working date of the method to date. The conditions for date to be considered a holiday are if it's stored in the holiday container as a regular holiday, or that means one time only, or if it's a recurring holiday, or if it's Sunday or Saturday. We have already implemented the get stored holiday if exists method, but not the get stored recurring holiday if it exists. However, the condition for this scenario is pretty straightforward. The get stored recurring holiday if it exists is basically about checking against the day, the month, and if it's recurring. The year should be disregarded. As far as Saturday and Sunday goes, we must define a new variable, for example, called regular holiday container, which is of type list, day of week, and stores the values Saturday and Sunday. With the container declared, we can now navigate to our method isHoliday, and we set isRegularHoliday be equal to regular holiday container contains day of the week, and we return an OR of these conditions. But bear in mind that this is not the most effective way to do this. Let's have a deeper look at this isHoliday method. The version on the top is how it's implemented now, and the version below is how it will be implemented in the future. Can you tell which version is more effective or efficient? It's actually the version below. But why? If you know, please leave a comment in the comment section. Back in our project, with the conditions for isHoliday complete, we now set the current working date equal to get next working day, and it takes in the current working date and compute positively as a parameter. We generate a method. We can go ahead and convert the current date time to time span. For that, we need a time span instantiation and pass in the start date. Well, we need to change the name of the current working date to start date and pass in the hour, minute, and seconds. Now, we could write this every time we need to convert, or we could simply mark the new time span section and control dot and extract method. Once that has been done, we can then rename the method to something like get time span and return current time span. One way to return a value is as follows: equal arrow forward arrow, and that's it. Now the value is returned. As it turns out, current time span is not actually required in the get next working day. So we remove it, but we'll keep the get time span method because we will surely need it. Instead, we define a variable called output date and initialize it to start date. And we write a do while loop. Do while is holiday of output date, and inside the while loop we set output date equals to output date add days plus 1 if we're computing positively, and set it to add days -1 if we are computing negatively. And we simply return the output date once the loop has terminated. With the method now ready, we can click on the references above it and go back to the color method. In here, we can specify the else condition. Else, if is within working hours of current working date equals false. That means if it's not within working hours, the next thing we'll do is set the current working date equal to get next working start date and pass in the current working date and compute positively. Now we need to implement two methods, is within working hours and get next working start date. We start off by implementing is within working hours. We change the parameter to date and we convert it to time span, so now the get time span method comes in handy. The next thing we do is check if the workday stop time is greater than the workday start time. Basically, if we work from 8 to 4 p.m., then we return the workday start time lower or equal than time span and workday stop time greater or equal than time span. Else, we return stored workday start time lower or equal than time span or workday stop time greater or equal than time span. This entire condition can be moved into a method of its own. So we extract the method, we name it exactly the same as the method it's coming from, and we decide that the parameter should be of type time span, parameter name time span. Now we don't need a variable time span anymore, we can just pass in the get time span directly. Now if we navigate back to the method of origin, we can change this slightly, remove equals false and set not the exclamation point is within working hours. That is actually equivalent. The next method we'll implement is get next working start date. And just as previously, we will start by retrieving the time span based on the date. We set current time span equals get time span current working date. We change that to start date. Then we set the variable start point time span, which is basically either the start workday start time or the workday stop time, depending on if we are computing positively or not. And then we set the output date with the initial value set by both the start date, where the year, month, and day is retained, and the start point time span, where the hours, minutes, and seconds are retained. The next thing we want to do is introduce a do-while loop. The do-while loop will have the condition is holiday output date and return output date. Inside the do-while loop, we'll check for if compute positively is true. Then we check for if the current time span is greater or equal than work date start time, or if is holiday, then we want to add 1 day to output date. Else, If just copy that over. If current time span is lower or equal to workday stop time, then we want to add it with minus 1 day. That basically is the equivalent of subtracting. We go to the reference and back to our calling method and add an else to the if not this working hours condition. Time span current working time equals get time span of current working date. And then we introduce a new variable called current workday length, which we set to be equivalent to workday stop time minus current working time if computing positively, or current working time minus workday start time if computing negatively. If the current workday length is lower than time span 0, we just add the current workday length with 24 hours. If current workday length is greater than normal workday length, which is actually the working hours, we set the current workday length equal to 24 hours minus current workday length. So the current workday length is nothing more than based on whether it's positive or not, or whether it falls outside of the normal workday length. The effective work hours increment is set to equal effective work hour increment minus workday length. We can write it in two different ways, either as above or as below. We just comment out the version that is above for reference. Continuing, if effective hours, work hours increment is lower than time span 0, then we set the time span current end time, which is basically what we're trying to calculate, equal get time span of current working date. If computing positively, we set the current end time to be equal to workday stop time minus current end time plus effective work hours increment. If the work day start time is greater than the workday stop time, this is virtually if we start from 11 p.m. and end at 7 a.m., then we just add 24 hours to the current end time. Else, if not computing positively, we set the current end time equal to work day start time minus current end time minus effective work hours increment, and then we do virtually the same check we did above. If workday start time is greater than workday stop time, we now subtract 24 hours. Now we set current working date equals current working date add end time. We just add the current end time to the current working date. And then we finally check if it is a holiday. Then we just get the next working day by passing in the current working date and compute positively parameters. and we set the current working day to output date. We can either set a break here to exit the while loop, but for clarity, we just gonna remove it and set allocating working time to false instead. Else, in relation to effective work hours increment lower or equal to time span 0, this basically means that effective work hours increment is greater than 0. We set the current working date to equal get next working start date by passing the current working date and compute positively. Now it seems to be a problem here. We trying to return the output date, but it's not accessible to us at this. It's out of scope at this point, but we expect it to be accessible. So what happened? It would appear output date is enclosed in the scope it's not supposed to be. So we scroll up and we see that within the if normal workday length is lower than time span 0, a range of variables are declared, including output date, and they're not supposed to be declared here. The only thing that needs to be here is the statement normal workday length equals workday length add 24 hours. So we enclose that and we navigate to the bottom right before return output and remove that bracket, closing bracket. Now output date should be accessible. And what we can do is format a document so that it looks a little bit more clear. And we can do that in Visual Studio for Windows by clicking on Ctrl K, Ctrl D. With the last method complete, we can now go ahead and start to beautify our code. I will pause the video for now and get back when ready. Now we are almost done beautifying our code. The first thing you'll maybe notice is that A and B have been swapped. The calendar type we thought it was a good idea to define before defining the month types. As you can see, there's a list of what's done and what's partially done. On the done block, we have get time span now is no longer a static method. That's the point number one. Number two is that we have renamed all methods starting with uppercase, as you can maybe see a glimpse of. And to rename is Ctrl R, Ctrl R. We have reordered the methods based on how they are invoked. We have on the number 4 extracted reuse code to method. See get 24 hours time span. There's also another method called get workday increment. And on the number 5, we decided it was a good idea to better expose public members. And the ones we would like to better expose are holidays, workday start time, and workday stop time. So the first thing we do is start off by setting the holidays to a private variable or private field, and we make it read only. This effectively means that the access of the list is a read only. Meanwhile, the contents are still accessible. As it was before, the access of the list was read only, but the content was public. We also renamed the holidays container to start holidays. And do the same thing with workday start time and workday stop time. We change them from properties to fields. And we also rename regular holiday container and changing its accessor to private. As you notice, I rename regular holiday container with a lowercase r to indicate that it's private. Now let's implement a get stored workday start time method that will be publicly accessible, and we just return the stored workday start time. The same thing we get workday stop time, but we return the stored workday stop time. In this way, we ensure that we have read only access to these two important variables. Now we start with something called public and INRMobile holiday, and the method is called get stored holidays and should return stored holiday. This is to discourage the consumer of the method from modifying it in any kind. And then we're done. The next thing we want to do is to ensure that everything is as it is supposed to be. We ensure that we get stored recurring holiday if exists is okay. Is holiday seems to be okay. Get time span is okay. Get working day increment. This is a new method after beautifying. And get next working day. As you can see, we've added the int increment there, which is compute positively set to 1, if not set to -1. We could basically call the get working day increment method here and pass in computes positively. So we avoid repeating ourselves, keeping it dry. So that's okay. Now we move on. Is working hours is okay. Both implementations. Get next working start date. We see that there's a new logic here that does basically the same thing as before, except that we have less code in the do while loop, which is preferable. We just have one if. And store holiday date looks okay as well. Set holiday looks okay. And we see that the get end time based on working day increments has implemented get 24-hour time spans instead of a new time span. That basically is it. We can conclude that we have completed the assignment, and the only thing that remains is testing. Testing will be displayed or illustrated in another video. But for now, be sure to subscribe if you like this content and comment in the comment section if you have anything to add or tips, and hit the like button. Have a good day.